This video will cover break-even analysis from many different perspectives, including calculating the profit or loss based on fixed cost and variable cost and the amount sold. The data that I'm using for this problem is from 7.22, the supplement to Chapter 7. What we have here is we are producing 5-pound bags of lettuce. We sell them for $2.50, and there are two processes that we are looking at. We have a manual process that has a much lower fixed cost, but our variable cost is much higher. We can go to more of a mechanized process where we buy additional equipment. The advantage is the variable cost goes down, but the fixed cost goes up. And this is very typical. So they've asked us to calculate the break-even point for the manual process, as well as the break-even point in dollars for the manual process, and the mechanized method as well, the break-even point in quantity and the break-even point in dollars. So to do this for the manual, let's start with the break-even point, the quantity. All you do is take the fixed cost, in this case the $37,500, and we're going to divide that by the difference between the price and the variable cost, $2.50 and $1.75. This is what is referred to as the contribution margin. So what's left after covering those costs directly associated with producing the bags of lettuce can then be contributed to the fixed cost. And once we've covered the fixed cost, then this contribution then becomes profit to us. But we're just trying to determine the point that we haven't lost any money and we haven't made any money. Where is the point that we've covered our fixed cost? And so that would be $50,000. Now, the break-even point in dollars, we could use the formula, or we could simply take this amount and multiply it by the $2.50. I'll come back and do that later and show you how to switch back and forth, but I'm going to use the formula here instead of just instantly converting this into dollars. So the formula for the break-even point in dollars is, once again, we want the fixed cost here. We're going to divide it by 1 minus this ratio, and the ratio is the variable cost divided by the price. So whatever that ratio is, we're going to subtract that from 1 and then divide that into our fixed cost, and that will tell us the dollar amount and break even. So instead of keeping track of how many bags of lettuce we have sold, when we know that we have collected $125,000 based on the sale of our lettuce, we will know that we have sold 50,000 bags of lettuce, and we've hit our break-even point. Now, as I mentioned, once you've done one of these, you can easily convert to the other. So let's say I wanted to convert the break-even point into dollars. As I mentioned, instead of using the formula, all I would do is I would simply take this, that's the quantity I need to sell, and if I want to just keep track of dollars, if I sell each bag of lettuce for $2.50, then I should collect $125,000. That means I sold 50,000 bags of lettuce. And so I get the same answer. Instead of using the formula, I can easily convert this. Or if I were to do this first, the break-even point in dollars, I can convert that back into quantity simply by taking this amount and dividing it by the sale price. So how many bags of lettuce is that? And once again, I get 50,000. So let's do the same thing for the mechanized and see where its break-even point is. So once again, the formula is our fixed cost for the break-even point in quantity divided by the price minus the variable cost. In this case, $1.25. So higher fixed cost but lower variable cost. And so we actually have to do 60,000 to hit the break-even point here. Now we can do that formula for the break-even point in dollars, or like I said, we can make the conversion. Let's go ahead and do that and then see if we get the same answer for the formula. So what I'm saying is I can simply go from this, the 60,000 times the price, and when I have $150,000, I will have sold 60,000 bags of lettuce. But let's use the formula, make sure that we get the same answer. So once again, it is the fixed cost divided by 1 minus this ratio, the variable to the price, the variable divided by the price, and then we subtract that from 1 and divide that into the fixed cost. And once again, we have the answer, $150,000. Now we can easily go back to this. So if we had used this formula first, all we would do is take that and divide that by $2.50 we get from every sale of lettuce, and that gives us back to the 60,000. So hopefully, if you've done one of these calculations, either the quantity or the dollars, you can easily convert to the other one without having to go through and do the formula again. Now here's where they ask us an interesting question. They basically say, well, for 60,000 bags of lettuce, what is the profit or loss? Now we know that in this case it is above the break-even point for the manual process. I'll come back and talk about the mechanized. So if we sell 60,000 bags of lettuce, we know that we're going to be on the profit side because our break-even point is 50,000. That's where we don't lose any money, but we don't make any money. So we know we're higher than that. It's simply a matter of calculating the sales revenue and then subtracting the total cost. So the sales revenue in this case is, if we're going to sell 60,000 and we're selling each of those bags of lettuce for $2.50, our sales revenue is $150,000. Our total cost is, of course, the fixed cost. That is not contingent upon any quantity. And we're going to add to that the variable cost. And the variable cost is contingent upon how many we sell. So if we don't sell any, our variable cost is nothing, but we still have the fixed cost. So we need to times this 60,000 times our variable cost, and that would give us our total cost. And so then to figure out, in this case, what our profit would be, because we know we're above the break-even point, you simply take the sales revenue and you minus the total cost. And that gives you the amount, $7,500 profit. Now, we can do the same thing for the mechanized. So they asked us to do that, 60,000. The sales revenue is going to be exactly the same. So 60,000, we don't change our price because of our process, so we know it's going to be the same. So it should be 150,000. Now in reality, I can tell you right now that I know the total cost is going to be 150,000. And I know that we're not going to lose anybody, but we're not going to make any money. Basically, our profit and loss is going to be zero. The reason I know that is, think about that. 60,000 is the break-even point for the mechanized. So we know that that's going to be the case. 60,000, if these match up, then the profit and loss is zero. We don't lose money, but we don't make money. But we'll verify that. So let's figure out the total cost. So we have this fixed cost plus we have then the variable cost. So it's 60,000 times the variable cost of $1.25, and it should equal 150,000. And so once again, 150,000 sales revenue minus the total cost. So in this case, if we had to make a decision, we would stay with the manual process because if we sell 60,000 bags of lettuce, we're above the break-even point, or we're at the break-even point, but the manual at least generates a profit for us. Now, the question they ask is the interesting one. Where does it switch from being manual to mechanized? Where does that remember we talked about this idea that the fixed cost, but there's a much steeper or a much higher variable cost. This starts out at a higher point, but this is not quite as steep of a slope if you think about it graphically. So sooner or later they're going to catch up to each other and cross. Well, really what we're talking about is looking at the cost comparisons, where the costs equal each other, because we know the sales revenue will always be the same, because we always charge the same price no matter what process we use. And so it's just a simple matter of solving for Q. So if I wanted to know where the mechanized process became more profitable than the manual process, I need to compare those costs. And where the costs are equal to each other, I know at that point everything below that quantity, the manual process will always be more profitable. And anything above that quantity, the mechanized process will be more profitable. As long as, I will put this caveat in there, as long as that quantity is above the break-even point of $50,000. The manual will always, or 50,000 as the quantity, will always be more profitable. But where is the point that the mechanized becomes more cost effective? So let's solve for that. So instead of just plugging in numbers and trying to figure out where the mechanized is more profitable than the manual, we can simply look at where the costs equal each other. So we have figured out this is the 37,500 plus $1.75 Q, and that is equal to then the 75,000 plus the $1.25 times Q. And then it's just a matter of solving for Q. So think back to your basic algebra class. I'm going to subtract 37,500 from both sides. So that will make this 0, and that will lower this amount. So we would wind up with 1.75, $1.75 times Q equal to 37,500, because I've subtracted 37,500 from both sides, plus $1.25 times Q. Now let's subtract $1.25 Q from both sides. So I'll subtract that. That will eliminate this one, and this will become 50 cents Q equal to 37,500. Now to get rid of the 50 cents times the Q, because it's multiplication, we divide. So if I were to then finish off, I'm going to divide both sides by 50 cents. So Q divided 0.5 times Q divided by 0.5 is Q, and then this one would be the 37,500 divided by Q. So I'm going to come back here and answer that right here. So this would be 37,500 divided by 0.5. 75,000. So at 75,000, the mechanized process will become more profitable. So every quantity below, as long as it's above the break-evens, and below 75,000, the manual will be more profitable. But at 75,000, then we have definitely covered all of the additional fixed costs, and we're now producing a quantity where the mechanized will actually become more profitable. Manual will still stay profitable, but the mechanized will deliver higher profits than the manual will, because the variable cost has now caught up. The costs equal at each other, and so in this case, then because the variable cost is lower, it will continue to be more profitable above 75,000. And so that's how you do break even.